This will be a brief introduction video to the Model 204 Heavy by Forest Manufacturing. Also include a test cut. Starting with a saw. This is a Model 204 vertical blade traveling table saw. These are high-speed machines. The Model 204 is built with two 20-inch diameter wheels, rated to carry up to a 1-inch wide blade. Blade speed on this machine is fixed at 3,000 feet per minute. That's a high-speed machine suitable for cutting plastic, foam, insulation, graphite, some metals, but mostly not. Aluminum, yes, steel, no. This machine has a couple of nice upgrades. First, it has our pneumatic blade tensioning system. So most medium, small size saws are going to have a screw over spring blade tensioning mechanism. This machine has the upgrade. The upgrade basically replaces a screw and spring with an air cylinder. The force of the air cylinder is controlled with an air pressure regulator mounted here on the backside where, sorry, you can't see it, and a manual control valve. So to tension and detension the blade, you just flick the switch. Setting the appropriate correct blade tension is done with the air pressure regulator. You just set the regulator to the appropriate pressure for the blade and you're locked in. You don't have to faff about with tension gauges or anything else. It's just done for you. And a correct blade tension leads to straight cuts and a long blade life. This machine also has a 5 horsepower blade drive motor. That's an upgrade from the standard 2 horsepower motor. For the stuff we'll be cutting today, that won't matter. It is worth noting though that the brake motor part is important. So start the motor, spins up, yay. When you stop it, the blade stops just about instantly. That's just good to know. When you make your cut, you press the blade, or press the blade stop button. The blade is not just spinning down slowly and silently, waiting to take your finger off. When you hit stop, the blade stops now, so you can reach in and touch the blade without taking your finger off. But still, don't touch the blade anyway. Heavy. So I have two variations on the Model 204. The standard 204 includes our cantilever style table, which is very convenient to work around, but it is limited in the amount of weight or the size of workpiece it can handle. For any of my customers who need to cut something large or heavy, or both, we have these heavy style tables. It basically just takes a caster mounted table and puts it on rails, so I can do a much larger table. We equip this with an operator guard and what I call a grocery cart handle. It's a nice place to just grab a hold, push the table. This machine also has our precision workpiece positioning fence. So think of this as a rip fence. It's synchronized left and right with gear racks running on linear round rail and has a double gear reduction between the crank handle and the actual gear does the moving, so it moves very smoothly. If you are a machinery guy, I would compare it to a lathe cross slide. Very tight, very precise, very satisfying. Unusually, the fence is mounted to the right of the blade. Typically we mount the fence to the left of the blade. Having it over here, the downside is it reduces your amount of horizontal throat you have in here. The upside is you can have a workpiece sitting here and extending however far that direction. When you mount the fence to the right of the blade, you're not using up any of that precious horizontal throat, which is good, but it limits you in how big a workpiece you can throw in here. So this one goes, I think it's like 48 inches, I don't remember the exact number, 48 inches to the right of the blade. So that's as big a workpiece you can stick in here. But it does free up some real estate inside the saw's horizontal throat. Usual features I've got of the saw is going into various features of this machine. That's the quickie. Today we are going to be cutting effectively a composite material. So this is a big piece of squishy, well not squishy, slightly squishy foam with plastic on either side. I would compare this to a structural insulated panel in that it's a composite material. Now, composite materials are tougher to cut for bandsaws or just about anything really. What you wind up in, the right blade to cut this foam is the wrong blade to cut this plastic, and the right blade to cut this plastic is the wrong blade to cut the foam. So we want to have a compromise. The compromise I'm using is a 1 inch wide, 16 tooth per inch blade. And again, running that high blade speed, 3,000 feet per minute. That'll do a reasonably good job of cutting the plastic without ripping it up too much. It'll also do a reasonably good job cutting the foam without turning it into a frayed mess. If I was just cutting the foam alone, I would use something like a scallop edge knife style blade, what you might think of as looking like a bread knife, such as you have at home in the kitchen. If I was just cutting this plastic, I would use something with much finer teeth, 24 or even 32 teeth per inch, to cut just the plastic. My 16 tooth per inch blade is a compromise, but I believe we'll get a good result on this material. Setting up a cut. So this is a light material. You can easily move it using the fence. So I can just come over here, run it over with the fence to where I want it. To keep the material, this is light material, and it has a low coefficient of friction with that plastic on the steel table, so it's going to want to slide around. To prevent that, I like to use magnets. This is a welding magnet, but it's a pretty beefy, good-sized magnet with a nice right angle on it. My table here is steel. 12 gauge steel top, 2 inch square tube framing underneath it, so it's very rigid and, of course, very friendly to magnets. So let's do a quick cut here. Start the saw. Safety note. This saw is very safe if you use it correctly. The correct way to make a cut with a bandsaw is to position the workpiece on the table, move the table to make the cut. Does two things for you. First off, it makes sure you're getting a straight cut. Let the table tracking mechanism define the direction of the cut, and you get a straight cut. And it keeps your hands, your fingers away from the blade while you're making the cut. So you get a straight cut, and you get to go home with all your fingers. Start the saw. Feed the workpiece into the blade. And we're done. That actually worked really well for a compromised blade. So you're seeing here some of the dust produced by cutting the plastic that's stuck to the foam. Comes right off. And let's see if the camera will focus on this. Right here on the cut edge, a little bit of furring, because I'm using a coarser blade than I'd really like to, but it comes off real easy. Just use my fingernail. And that cleans up with a pass or two of the fingernails. So, high quality, smooth, straight cut, very little to no cleanup required, and you go home with all your fingers. If you have any questions or would like to discuss a specific application, please feel free to call or email us here at Forest Manufacturing. Thank you for your time.